I asked him to come back. He said,
What'd you get?
I'm right.
21.
So you didn't have a meeting with the guys.
I'm so proud of myself.
Did you
You
know?
had negative or positive?
For the sheet?
You're wrong.
Yeah.
I got a positive.
But he's
Sorry,
at
this one.
right now.
Just stop talking.
There's negative 4 to the fourth power. Negative 4 being raised to the fourth power.
Oh, 4
Negative times
times.
a negative positive. Negative times a negative positive.
When is your test over this?
Tests or quiz next week.
Is it like on
We don't take it.
We don't school on Monday.
We don't.
Is that what you said?
All right. Hey guys, look at the worksheet from last night. That's not it. Is that it?
No.
No? Where the heck? Is that last night's homework? That was the worksheet, right?
Is it out on there?
No.
I can try to find it.
Hey guys, why don't we do number 3 here? Do number 3 right here. Then we'll go over the worksheet.
I also need to see if 5, 6 homework. Use 2 on the 5th.
Did we start? Okay. How do I get rid of that negative 4 exponent? What do I do inside the parentheses? Go ahead.
You switch the two. You switch the y3 from the bottom to x. And you switch both. You switch them.
Right? Just flip flop everything. Is everybody good with that? And then that changes to my exponent to positive 4. Corbin? Right? Come on. Everybody good? Okay, what is 2 to the 4th power? 16. Now, when you raise a power to a power, what do you do with the numbers? Multiply. What's negative 2 times 4, guys? Negative 8. What's 3 times 4? Okay. Everything's good, right? Alexis, what is wrong with my answer? I can't leave that negative 8, x to the negative 8. Where does it go? So tell me what my final answer is going to be, Alexis. No. Careful. Does the 16 go down below? No, 16's up. Hey, guys, say to the 12th. Y to the 12th. X to the 8th. Now, could you put the x first? Yeah. That doesn't change your answer. That's our answer there, okay? Okay, guys, looking at the worksheet, are there any the first 8, the top, that you want me to go over? That you saw the answers and it's like you're looking at it and go, that didn't make sense. 1 through 8 that you want me to do? Please ask. 1 through 8. You guys are good on 1 through 8? Okay, how about 9 through 14, the next set of 6? 9 through 14, any of those? Yeah, Leah?
14.
Yeah. I got 2 cubed. 8 to the negative 3rd. X to the negative 1. B to the negative 5th. And C 0. This is what? 14? Okay, Aaliyah. What can I cancel? What can I just cross out?
C0.
That's gone. What's 2 to the third?
No, I heard six.
No, 2 times 2 is 4
Oh,
times 2
16.
times 2. 2 is our base, not 4. It's 8. Okay, what happens to a to the negative third?
It goes to the bottom.
And becomes,
A to the positive third.
yep. Okay, so we're done with these two. What about a to the negative 1? Where does it go? Up, and it becomes 8 to the first, which is just 8. Now, here's where this is confusing. If I have two numbers, one's already up here, right? I'm bringing another number up. You have to multiply them. Okay? And then b to the negative fifth has to go where? Up. And becomes b to the fifth, right? So clean up what? 8 times 8 is what?
64.
And there's my answer. There's your answer right there. That was tricky because of that. Okay, what else, guys? How about 15 through 23? The rest. Which ones do you guys want to see? 15 through 23. Really? Come on. Nothing? Logan, which one?
22.
22. 4 over x. Is that right? To the negative third. Okay. What's my first step? Get rid of the negative 3 exponent. How? Huh? Flip. No. You can, but flip everything. And that becomes positive. These are both to the first power, right? Inside. What's 1 times 3?
X, 3.
X to the third. 1 times 3.
4
To the third. What's 4 to the third?
64.
Yeah. Does that make sense? Which one? Braden?
16.
16? Yeah. Braden, do I have common bases?
Yeah.
So I can subtract my exponents, right? Because I have common bases. Okay? So what's 7 minus 2? Or excuse me, I gave the answer. 7 minus 5 is 2. Where are there more of them at? Top or bottom? Top. So I'm just left with this. And what's negative 2 squared? 4. There's your answer. What else, guys? Any other ones? You guys all right? Okay, Mr. Westfall.
All ready for this?
Is that a song? You ready for this?
Radicals. Ooh, pretty radical.
What is that usually covered in? Algebra 2?
Geometry.
I've never seen it before in geometry.
Squares.
No.
Oh,
The like
2/3 power?
yes.
I don't get that. So freak out.
They said there's been like 1 or 2 problems on the state test. We've never gone over.
I'm gonna be honest with you guys. Some of today's lessons a bit of a reach. It's gonna be tough. All right.
Guys, he's over.
Can you you have to realize at the same time, if it's going to be on a state test, we have to prepare you for it, right? I would feel bad if you weren't prepared for it. So can we at least agree today that I will try my best to teach this in a way that makes sense? If you guys can try to just not complain and try to understand the analogies I'm going to use to explain it. Can we do that? All right. So I want to start you off thinking of something in a certain way. All right. You have to understand math in this context. You've grown up learning operations. I need you to listen here. Learning operations in certain ways. 2 plus, oh my gosh, this cannot happen today. All right. 2 2 plus 7 is 9. Right? Second grade, first grade. Actually, first grade. Maybe even kindergarten. 2 plus 7 is 9. And then you learn subtraction. How would you explain 2 plus 7 equals 9? How would you teach someone subtraction using this process? Leah.
9 minus 2 equals 7.
Let's go backwards. 9 minus
7 equals 2.
okay, 9 minus 7 equals 2. Then you bumped it up. 2 times 7 is 14. So then you talked about division being 14 divided by 7 equals 2. You with me? These were called inverse operations of one another. Inverse operation. Every operation had to have an inverse operation. Do you agree with me? Okay? Well, let's keep going. Now we're bumping up to this year. All right. 2 to the, nope. 3 to the second power is 9. So, what's the inverse operation of that process? Not subtraction, not addition, not multiplication, not division. It's something that have you learned it yet? Very good. So the square root of 9 is 3. Do you agree with that? Squaring and square rooting are inverse operations. All right. 2 to the third power is 8. So, wait a minute. Going squaring, I got 9. Square rooting, I went backwards, I got 3. Cubing, I got 8. Do you know a name for that? Put backwards? Let's call it cube rooting. It's actually called that. Good job.
Action?
Cube
Oh,
rooting.
that was emotional.
Cube rooting. The cube root of 8 is 2. All right. Let's think about this in another way. Okay? You're walking into a fenced area. Okay? You know how when you walk into a fenced area, you have to open the gate. Right? Either you push it open or you pull it open, but you have to open the gate. Whenever you come back the other way, you have to do the opposite process. Whatever got you in, you had to get out the same way. All right? So if I cube to get in, I have to cube root to get out, to get back to the original number. If I squared to get in, I cube root to get back. Let's see what about this? What's 2 to the fourth power? 16. Good. 2 times 2 times 2 times 2, 16. Yes?
Yeah.
So, what root should we call that? Not square root, not cube root. Fourth root.
Quadroot.
Let's go.
The fourth root of 16 is 2. All right, let's make it a little bit more complex. X to the fourth is 16. We can actually solve this without even doing anything. You could guess and check. You're thinking, okay, what number x, when I raise it to the fourth power, equals 6? Okay, it's 2, right? Now, we have to show it with algebra. What undoes a fourth power? A fourth root undoes a power of 4, doesn't it? Didn't it get us back to where we started? And if I fourth root this side, I have to fourth root that side. Now here's the question. What does this look like? x to the fourth Well, do you remember how if we multiplied by 2, dividing by 2 is the inverse operation? If we added 7, subtracting 7 was the inverse operation. A power of 4 and a fourth root power cancel and give us x. That's the inverse operation. Do you get that? If something's squared, what's the inverse operation to get rid of it? Square root. If something's cubed, what's the inverse operation? Cube root. It's whatever power raised to that power will give you an exponent of 1. We'll talk about that later. Okay?
Will it be like a 15 root?
We'll never get to that, no. So x is 2 for this problem. All right, so now that we talked about that, this should be make a little bit more sense. If 4 times 4 is 4 squared, and that's 16, isn't the square root of 16 4? Didn't that get us back to where we started? Okay. What's negative 4 times negative 4? Negative 4 squared, which is 16. Okay. Now, the only way that can be negative is if you have to work backwards and think, well, here's a little example. I've got 2 numbers behind my back. Okay. I got 2 pairs of numbers behind my back. They both multiply to 16. One of them has to be 4 times 4. That's one pair. 4 times 4 gives you 16. Could it be negative 4 times negative 4? Yeah. So both of them are acceptable answers, right? Both of them, when you square them, can give you 16. You don't know which one it is. It could have been either one. All right? So that's if you're uncovering. So let's talk about this. Let's practice our square roots and cube roots. This is a square root. They won't put a 2 there. They won't put a 2 there. Any other root, like a cube root or fourth root, they have to put a 3 or a 4 there. If it's nothing there, it's understood to be a square root. A square root asks what question? What number times itself? Okay? Gives you that number. What's the square root of 1? 1. What's the square root of 4? 2. What's the square root of 9? Square root of 16?
4.
Very good. What's the cube root of 1? Now it's a different question. Now it's not what number times itself. It's what number times itself again gives me that number. What's the cube root of 1?
1.
Cube root of 8? Cube root of 27.
3.
3 times 3 times 3 is 27. Very good. Cube root of 64.
4.
Check. It's 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. Now, let's check it in our calculator. Let's learn how to take a cube root in our calculator. Do you see the button that has a root with an X above it? It's the caret button, but it's the blue above it. Do you see it?
Mm-hmm.
Okay, now don't type anything in yet. Here's how you have to type it in your calculator. Do you see how it's an X up there?
Yeah.
It's an X up there because that could be a cube root, fourth root, fifth root, sixth root. You have to tell it what root to put in. So here's how you have to type it in your calculator. 3, and then second that button to get the Xth root, and then 64. And then hit equals. Did you get 4?
I got 24.
No, yeah.
Oh. 3,
So good.
3, second caret.
No, he's not here. You're welcome. Was he marked absent? Yeah, he's not here.
Which one? Who's the X?
Brock.
He's with.
He says Matt says it was Sam. Yeah. Okay, bye-bye.
Or supposed to be.
I did it.
Here, I'll show you.
He's the cube root master.
You're gonna hit 3.
All right, now.
You guys know how to get that on your calculators? Everybody see it? Anybody having trouble getting cube root on the calculator? I can show you.
Sabrina needs a little help. All right. Now, these roots have other ways that they look. They look two different ways. They can be written either with a square root or it's the same as having a 1/2 power. That's kind of weird. So what if I ask you what's 16 to the 1/2 power? Well, that's the same as asking what is the square root of 16? It's 4. The cube root of 27 is the same as 27 to the 1/3 power. Either way, that is 3. You like that? You like the way that looks better?
The 1/3 better. 2/3.
I was gonna say, like, kind of already tells you your answer if it's like written in the half form,
Yeah.
Why is that?
because under the 1 there's a 2 and then equals 2.
What's the square root of what's 16 to the 1/2?
2. I mean 4.
4. All right.
We're missing this again.
Okay, so you can take. Okay, I'll talk to you.
All right. This, I'm going to be honest, this up here is going to just be too confusing right now. All right. All right. Example 1. Find the indicated real nth roots of A. All right. Nth
What?
root. Well, guess what? If n is 2, they're asking us for a square root. If n is 3, they're asking us for a
3
cube root. 4th root, 5th root, right? So when they say n is 2, we know what they're really trying to say. They're trying to say find whatever a is and raise it to the 1/2 power. Do you agree? What's 49 to the 1/2 power? 7. Yeah, I actually disagree with what they're writing up there. All right,
Or you can write it as the other way too, right?
3 powers. And they
square
go-
root.
Square root.
Well, this tells me to take negative 64 and raise it to the 1/3. Now, before you type this in, is the number going to be negative or positive?
Did you show them how to get the 49 to the 1/2 power? Did you show them how to do that? Did you talk about that in the calculator?
No. So 49 to the 1/2.
You just do.
I told you to do square root, but you can also do this. 49 parentheses caret and then parentheses 1 divided by 2.
Or you could just do 49 caret and then 1 ABC2. Just type in parentheses.
For 1/2?
49 caret.
What'd you get for the cube root of negative 64? Negative what? Negative 4? All right, now we have 16 to the what power? 1/4, which is
2.
2. All right. I actually disagree with them on this.
Which one don't you like?
They're saying if n is even, then a has 2 real nth roots.
I think what they're saying there's positive or negative.
But it's not for that.
Which one?
49 to the 1/2 is not positive and negative 7.
No?
Because they're telling you to take the square root of 49. They're not saying,
Square root of 49 though would be plus or minus that. Why not?
there's two questions. So there's find the square root of 49, and there's x squared equals 49. This one tells you find the square root of 49. If they want it to be negative, they'd have to put a negative out front. This one says I'm squaring a number and I get 49. It could be x could be 7 or x could be negative 7.
But I think they're going with the premise if negative 7 times negative 7 is 49, so the square root of 49 could be a positive or negative.
Were you getting 7 and negative 7?
Because 7 and negative 7 times negative 7 is 49, just like 7 times 7 is. So the square root of 49 is positive 7 and negative 7.
We have to talk about it later.
Okay.
There's a graph. I mean, there's. Let's say that for another day. All right. If they just present you with find the square root of 25, there's only one solution. What's the square root of 25? 5. All right. What's the fourth root of 16?
2.
And you should always be thinking in the back of your mind, okay, what times what times what times what is 16? Okay, it's 2. What's the cube root of negative 8? Negative 2, very good. What's the cube root of 64?
4.
4. You guys are good with this, right? Awesome. All right, now these ones, this is the part that I think is a little trickier, but if you guys can really focus, I think we can get through this. All right, before you solve anything, I want you to think of something. Okay, before we type this in our calculator, I'm going to rewrite this. 16 to the 3/2 can be rewritten. Okay. Do you remember how yesterday we did a power to a power and we multiplied? Yes. So we learned a rule. A power to a power, we can multiply the exponents. What power to a power must this have been? If we multiply them, we would get 3/2. 3 times what is 3/2? 3 times... Isn't 3 times 1/2? 3/2. So this could be, tell me if you think this is the same or not. 16 to the 1/2 power, and then take that and cube it. If you raise this power to that power and multiply, will you get the same thing as this? You would, wouldn't you? Okay, because a power to a power, you multiply. Now, can I solve this? Well, I work from inside out. What's the square root of 16? This is 4. And what is 4 cubed? 64. Let's check it in our calculator. 16 caret 3 divided by 2 in parentheses. Did he just have him do this in the calculator?
Yeah, he showed him a couple ways to write it. Like he did like square root of 16, and then in parentheses 3, and then like you did there. Not like he didn't write it like 16 to 1/2 raised it. I like that though.
All right, let's think back to this one. What two things could have been multiplied to get 2/3? 2 times 1/3.
Oh yeah. And then
Isn't 2 times 1/3 2/3?
Yeah.
Or 1/3 times 2. Do you agree?
Yeah.
Here's what I always do. I take the root first. Let me explain why. First of all, check that. Is that right? is 8 to the 1/3 and then squared. Is that the same as 8 to the 2/3? Yes. Now wait a minute. Before you guys type anything, just look up here for a second. Here's why I write it this way. Could I have written this as 8 squared to the 1/3? Well, what's 2 times a third? It still works, doesn't it? Doesn't it work because multiplication can be done in any order? Why don't I want to do it this way? Well, what's this doing? Isn't it squaring 8 first, which gets to be a big number? And then I have to take the cube root of a big number? I'd rather take the cube root first and get a little number and then square that number. Do you see what I'm saying? What's 8 to the 1/3? 2. And what's 2 squared? 4. And you can type that in and make sure that's the right answer. Getting it? Use parentheses for that exponent.
It's a good long weekend.
See, Mr. Parker.
Thank you.
All right, this is from a state end of course test. Select all of the expressions that are equivalent. Now you could go through, you could type that in, 16 to the 5/2. Isn't this the same as 16 to the 1/2 and then to the 5th? What's 16 to the 1/2? What's the square root of 16? 4 to the 5th?
100 or 1,024.
4 to the 5th?
4.
1,024.
Is it 1,024? So 1,024 is the integer, the whole number representation of it. So I would probably type in, well, we know it's 4 to the 5th. We know that one's right, don't we? Because we just did what's 4 to the 5th. That one's right. How about 8 to the 5th? Can't be right because it's 4 to the 5th. So that one's not right. How about the square root of 16 to the 5th? Well, isn't 16 to the 1/2 the square root of 16 to the 5th? So that one's good. This one I would want to check. This one is 16 squared to the 1/5. Power to a power you multiply. That would be 16 to the 2/5. That's not 16 to the 5/2, is it? So not that one. What do you do when you multiply things that have a common base? What do you do with their exponents? That's dividing. Add. When you multiply bases, you add their exponents. So this is going to be 16 to the 2 plus 1/2. What's 2 plus 1/2? What's 2 plus 1/2? Isn't it 5/2? Yeah. And isn't that what they started us off with?
Yeah.
So that's good. How about this guy? Multiply bases, add their exponents.
Yes. Yes.
5 plus 1/2.
Or not plus.
Give me a decimal for 5/2.
2.5.
2.5, right? 5.5 is not 2.5. You agree with that? So that one is not correct. So I would have checked these 3. All right, last slide for today. Rewrite the expression in rational exponent form. Rational exponent form would be this. I'll help you out with the first one. 21 to the 1/3. For that one, yeah. They don't want us to evaluate it, just rewrite it in rational exponent form. What'd you get for the second one? 6 to the, it's 6 cubed to the 1/5. How would you rewrite that as in a rational form? 6 to the power to a power you multiply. What's 3 times the 5th? 3/5. Again, we're just rewriting it. We're not solving it. All right, I want to make sure you guys get to this one. I want you to rewrite 7 to the 3/4. See if you can figure that one out. In a power to a power format.
What are we rewriting?
In a power to a power form, like 7 to the blank raised to the blank. Zachary, what'd you get?
7 to the third power, 4th root.
I agree with that. Or 7 to the. Everybody else do it differently? 7 to the 1/4 and then cubed. Wouldn't both of those give you 3/4 when you multiply their exponents? That's tough. So when they say radical form, this would be the 4th root of 7 cubed. This one would be the blank root of 20. 5th root, and it goes like that. That little 5 goes there. Full contact social studies today. Homework.
What? What did you say?
There's been 4 days to complete it. I think we'll be fine.
That was not easy. I appreciate you guys. You guys worked hard today. I appreciate that.